Now, this is what the model of the neuron, what we have seen, that is UK, multiplication of the input with the weights. And then this UK is going to be added with the BK here actually. And this VK is going to form as an input to this particular function. That is, bias is getting treated as a separate input along with this. Now we'll look at the case actually where we will consider this bias as an input, because I should take it as a BK itself actually. But we'll fix the input to the first input x naught with the plus 1, because 1 multiplied with BK, it becomes a BK itself actually, nothing else actually. And we will consider this BK as WK0. That is, whatever the bias value we want to provide, whether it is 0 or less than 0 or greater than 0, that we can provide as this particular input. That is, instead of the separate as in a BK here, we are considering this input bias as an input itself, but the input signal is fixed at 1 year actually. And bias value is being considered with the weight as a WK0 actually. Therefore, now you observe this expression here actually, this one actually. It is WK0 and X0, because J is equal to 0 to M, and next term is WK1 and X1, and then WK2 and then X2. It keeps going up to that is sorry, 1 minute, WKM and XM. Because earlier our expression was ranging from 1 to M here, but now this expression is going to go from 0 to 1. And we are going to tell the x naught is plus 1 and BK is nothing but WK0. And this same input, that is, we are passing it to the BK. Because earlier what we had, because this x naught term was not there, it was starting from 1. Therefore, we used to have here VK plus BK. But now we have included starting from 0, therefore this BK will not come actually. That is just for a simplification purpose, nothing else actually, because we want to treat this bias as an input itself actually. Okay.